welcome back. This is part 2 of our fluid flow analysis video. In this one, we're going to go over the actual fluid flow analysis. So we're going to do that by starting and clicking the setup. As you can see in our main, here we're going to go and switch under options. We're going to click on double precision. Okay. So once we do this, we're going to go ahead and hit the OK button on the fluid launcher. Anytime he feels like doing that, that'd be great. Okay. Alright, this is going to open our actual fluid flow analysis. You should come up with an image that looks something like this. We're going to go ahead and full screen it for you guys to make it seem a little bigger. Alright, first thing we're going to do is we're going to change the materials that we're working with. So we're going to go to our tree and select on materials. We're going to go ahead down underneath this. We're going to click create and edit. This allows us to change the materials that we're working with. So we're going to change our density from 1.225 to just a solid 1. And we're going to change viscosity up to 0.05 kilograms per meter second. Hit change and create, and then we're going to go ahead and close out of this window. Alright, now that we've updated our working materials, we're going to go to models and make sure that our models is set to viscous laminar. This is very important that you change it to viscous laminar because this is what we're going to be working with. Alright, once we've selected viscous laminar, we're going to go down to boundary conditions. We're going to change far field 1, hit edit, and change type from wall to velocity inlet. We're going to change our velocity specification method to components and change our x velocity to just 1 meter per second. Go ahead and hit OK. Once you've done that, we're going to go down to far field 2, change it once again from wall to pressure outlet. We're just going to go ahead and hit OK, nothing to change on that there. Once we do that, we're going to go to cylinder wall. We're going to leave this one, make sure it's set on wall, and just leave it on wall. Alright, once we've set up our boundary conditions, this is all the boundary conditions we need to do. We're going to go to reference values. This allows us to change what the fluids are based on, so we're going to change compute from blank here. We're going to switch that to far field 1. This sets up our reference values to how we had initialized it in far field 1. Okay, once we do that, this is probably a good time to go ahead and save what you've done so far. So we're going to save our project really quick. Give it a second to save. Now that we've saved it, we're going to go ahead and set up our solutions methods. Now that we do that, we're just going to go ahead and make sure it looks like everything we got on the screen here, that the pressure is set to second order and our momentum is set to second order upline. If that's what it looks like, that's good. We're going to go ahead and go down to solution initialization, switch it from hybrid initialization to standard initialization. Once again, we're going to click compute from, and we're going to select that far field 1 like we did the first time. We're going to go ahead and go to the bottom and hit initialize. Okay, now that we've set up our initialization, we're going to go to monitors. This allows us to actually track how it changes every time. So we're going to hit edit on the residuals print plot. We're going to change our numbers over here from 0.01 to 1e to the -6. It gives us a lot greater accuracy here. Change all 3 of those, and we're going to go ahead and hit OK. Okay, that's the last of our setup. We're going to go to run calculation, change the number of iterations to 2,000. It might not actually take all 2,000 iterations to process our fluid flow, but that's the maximum we want to see, so we're going to go ahead and hit calculate. Once we hit calculate, it might take a minute or 2 to run depending on how quick your computer works, but as you can see, it'll actively track our solution here. Okay, so we skipped over most of the actual calculation of the solution here because it took us about a minute and a half to do. As you can see, it only took us about 1,660 iterations to get to the end. It should pop up with this nice calculation complete logo here. Once we do this, this is our final solution. We're going to go ahead and click Save Picture. This is a little icon on the left side of our screen printout here. It looks like a little camera. So we're going to go ahead and click that right there. Under our options, we're going to click off the white background. This allows us to have a colored background. So click that off. Once we do that, we're going to go ahead and hit Save. You're allowed to save this wherever you want to. Hit OK. We're not going to actually save it because we've saved these pictures before. Okay, now that you've run this and saved that picture, this is probably a good time to save our project. It's always a good idea to save it in case the computer crashes or you mess up. Once you save that, we're going to go down to, on our tree on the left side here, we're going to go down to animations. Once we do that, we're going to go ahead and click on vectors. We're going to hit set. Alright, we're going to make our vectors of velocity here. So if you want to change the size of the arrows, you can go underneath arrow, go to scale. Change that scale from 1 up to about 4. Okay, so now that we did this, we didn't actually do it in the video, but we'll go ahead and hit display. It should come up with an image that looks something like this. Go ahead and close that window. So we're going to zoom in. You can see it gives us a vector field around this inner cylinder here. It's probably a good time to go ahead and save this image, once again using that little camera over on the left side of the window. Okay, so we're going to go ahead, go back under our tree. Alright, we're going to change from vectors to contours here. We're going to change our contours from pressure down to velocity. We're going to go over to levels over here and switch levels up from 20 up to about 100. This gives us a little more accuracy on our detail here on the contour plot. Okay, once you do this, go ahead and hit display. It should come up with an image that looks like this. You can see, so we can go ahead and we're going to zoom in really quick on the contours plot and close out that window. Once again, this is a good time to go ahead and save your image by using the little camera over on the left side of our screen and saving it. Alright, now that we do that, we're going to do one more contour plot. So we're going to go back to contours, hit setup, change it from velocity magnitude to stream function. We're going to change it from auto range in the options to clip to range and switch from 31 in our minimum to 33 as our maximum and hit display. This just gives us the contour plot right around the center of our line here. So once again, we'll go ahead and zoom in, look at our plot here, and close out the contour window. And once again, good time to save the plot. Okay, so this is the last of the actual images we're going to be doing. Now we're going to be going over to reports in our tree here. We're going to select forces. We're going to go to setup, and that's about it. We're going to go ahead and print it. It should come out in your console and give you a bunch of data that looks like this. So we're going to go ahead and copy all of our data over from this table, and we're just going to paste it into Notepad. It makes it a little bit easier to look at and save the data. So open Notepad, we're going to go ahead and paste it, and all our data should look something like this. This is all our data. Alright, we're just going to go ahead and save our data really quick. Once you save your data, that's about all that there is left in this tutorial, okay? So we went over how to set up our basic fluid flow analysis using ANSYS Fluent, and then how to do various contours and vector fields, and then how to print out the actual data and save it. Thank you guys very much.